Hello, and welcome back to my series on the AP Calculus BC 2024 FRQs. In this video, I'll be doing FRQ 4. The graph of the differentiable function f is shown for -6 less than or equal to x less than or equal to 7. It has a horizontal tangent at x equals -2 and is linear between 0 and 7. And the shaded region R has area 12, as shown in the picture. So for A, the question asks, the function g is defined by g of x equals the integral from 0 to x of f of t dt, and then it asks to find the values of g of -6, g of 4, and g of 6. Okay, so g of -6 is equal to the definite integral from 0 to -6 of f of t dt. Now, the thing about that is, notice how this number on the bottom is less than this number on the top. The limits of the integral are in an order in which on the bottom we have a number that is less than the one on the top. That means that any area we count for, we have to multiply it by -1. Or we could just do this, and to make this just a little bit easier, we can just flip the bounds. When you flip the bounds of an integral, you have to multiply the integral by -1. Like, as I said, if the you'd have to count for the area negatively if you flip the bounds. So the integral from -6 to 0 of f of t dt is 12, and that's given to us because the integral from -6 to 0 of f of t dt is the area under the curve of f of t from -6 to 0. So that's given to us as 12. And now what we need to do is multiply that by -1, and that's -12. So g of -6 equals -12. G of 4 is the definite integral from 0 to 4 of f of t dt, and the area under the curve for f of t from 0 to 4 is a triangle with height 2 and base 4. Using the formula for area of a triangle, 1/2 base times height, or 1/2 height times base in this case, just because I switched them up. That equals 4. Now, for g of 6, that's the area under the curve from 0 to 6 of f of t dt, and we'll notice that it covers that portion from 0 to 4 first, and then it keeps on going. However, as it goes past 4, it starts to go below the x-axis. So that means any area that counts from that point on is negative, since it's below the x-axis. So the area that happens to be below the x-axis from 4 to 6 is a triangle with height 1 and base 2. So 4 minus 1/2 base times height. And that equals 4 minus 1, and that equals 3. Now for problem B. For the function g defined in part A, find all values of x on the interval 0 less than or equal to x less than or equal to 6, at which the graph of g has a critical point. Okay, so g of x equals the definite integral from 0 to x of f of t dt. G prime of x by the fundamental theorem of calculus equals f of x. Just keep in mind that when we have a function, let's call it h of x in this case, h of x equals the definite integral from some constant a to some function g of x of f of x dx. H prime of x is equal to f of g of x times g prime of x. Now this is by the fundamental theorem of calculus, and we don't need to worry about any function of g of x because it's just x by itself. So if you have it from a constant to x, it's just take that x, put it in here. So g prime of x is equal to f of x. And remember that we have a critical point when the derivative is equal to 0 or does not exist. Well, on the interval 0 to 6, f of x equals 0 at x equals 4 for x between 0 and 6. There's nowhere where f does not exist, and f of x equals 0 at x equals 4, so there's a critical point at x equals 4. That is where the derivative of g prime, which is also equal to f of x, equals 0. Now for c. H of x is defined by integral from -6 to x of f prime of t dt. Find the values of h of 6, h prime of 6, and h prime prime of 6. Alright, so first of all, h of x is equal to the antiderivative of f prime of t, which is f of t, evaluated from -6 to x. And that's going to be f of x minus f of -6 by the fundamental theorem of calculus. F of -6 from the graph is 0.5. So h of x equals f of x minus 0.5. H prime of x equals f prime of x. H prime prime of x equals f prime prime of x. So h of 6 equals f of 6 minus 0.5. F of 6 is -1 according to the graph. So -1 minus 0.5 equals -1.5. H prime of 6 is equal to f prime of 6, and that is -1/2. Now, the reason it's -1/2 is because we can see that for the portion around 6, it's linear. F of x is linear, and it has a negative slope, and that slope is just counting the rise over run, and that is just -1/2. It even mentions that for x between 0 and 7, it's linear. So just finding that slope would just be, so it would be -1 over 2. That's -1/2. H prime prime of 6 is equal to f prime prime of 6, and f prime prime of 6 is equal to 0. Now, why? Because f of x is linear at x equals 6. That's because it tells us in the problem, and the reason that h prime prime of 6 and f prime prime of 6 are 0 are because for this entire area from 0 to 7, f prime of x is constant at -1/2. Therefore, f prime prime of x is equal to 0, because that derivative of that constant at any point from there, from 0 to 7, is just going to be 0. So those are our answers. Thanks so much for watching. If you found this helpful, I would appreciate if you could like and subscribe, and I'll see you guys in the next video.